Hi students, cherish chemistry. Okay, only when we cherish and appreciate the chemistry in and around us, it is the real learning. Today, we'll be discussing on energy, and here I've given you the overview of what we're going to learn. Okay, so we'll be discussing about what is energy. We live, we eat, we sleep, for everything in our life, the central aspect is energy. So we will be discussing on that and the various types of energy, potential energy, kinetic energy, and different examples. I'll be describing that with various examples and the sources of energy. So we have a lot of sources of energy. We are dependent on that. So in that, the main classification which we'll be doing is renewable and non-renewable resources. So shall we go to the slideshow? Come.
Hi students, today we'll be discussing on energy. So that forms the central aspect of all our science subjects. Okay, yeah, so we'll move on with the slides. Yeah, so energy is the ability to do work. When we can work, that is because of energy, and energy will cause change. If there should be some changes, that is because of energy. Anything for that matter. We sit, we stand, we run, everything is a change, and that is because of energy. There are two different forms of energy, potential and kinetic energy. It's a scalar quantity, and it is given a meaning. A quantitative value is obtained only through the calculation of potential energy and kinetic energy used on the formulas. And as I told you, yes, it is a central concept in science. Now here you see the pictures of people walking, running, carrying something, driving. Everything is possible only if energy is possessed in us. And here I've given the classification of potential and kinetic energy. This is the stored form of energy, and this is the energy which we can move. Okay, so how do we define this potential energy? If the position of an object is unaltered, that would create potential energy. Okay, so I will take an example of a rubber band. I stretch the rubber band and I keep it without doing nothing, and that is your potential energy. The energy is stored in the rubber band which is stretched. So there are a lot of examples. Drawing a bow, which we have stretched, we have not let it, but that is an example, classic example of potential energy. And how do we calculate that? For that you need the object's weight, gravity of the earth, and height. So when we multiply all these three quantitative parameters, we get potential energy. There are various classification in potential energy itself. It's based on gravitational. I'm going to leave a ball from a height, so that comes under gravitational potential energy. Electromagnetic potential energy, nuclear potential energy, very important. The nuclear weapons that is there, so in that so much of energy is stored, but when it starts reacting, or when the reaction starts, the energy that is let out from the nuclear weapon is immeasurable. And a weak nuclear potential energy, a radioactive decay, so that can come under weak nuclear potential energy. Yeah, this is what I spoke about, the gravitational energy. When an object is lifted from the land, okay, so it would gain that gravitational energy. So when anything is elevated and it is remaining still, so that is gravitational energy. And your stored mechanical energy, the rubber band, again the example that I gave, anything that is having a push or pull on an object and it remains still, again that is your stored mechanical energy. And the next one is nuclear energy. As I told you, very important, the energy that is stored in the nucleus, that is going to change the world. There are so many fights on that. So energy is stored in the nucleus of the atom. That will hold the nucleus together, and that carries so much of energy. Chemical energy. Any atom, any molecules, the bond between these atoms will carry an energy. So how are these atoms bonded? That's because of the energy between them. So energy is stored in the bonds between the atoms. So much of energy is between the atoms. So that is stored chemical energy again. And talking about kinetic energy. So if anything starts to move, then it comes under kinetic energy. Then it requires kinetic energy. So movement of objects or substances from one place to another, it is known as kinetic energy. And how do we calculate that? Kinetic energy is equal to half mv squared. So we need the mass and we need the velocity of that particular object. Yeah, so this again the same example that I gave you. When we stretch the bow and when we remain still, that is potential energy. But when we leave it, that comes under kinetic energy. The yo-yo and the rubber band example, that also comes under kinetic energy. Yes, okay. So this is movement of sound. So that comes under sound energy. So when we talk, the sound waves that travels, okay, so anything that moves again. And this is about movement of electrons, the electricity. So that comes under kinetic energy, and that is our electrical energy. Yeah. Heat, light energy. So when light falls or when light travels from one place to the other, that comes under radiant energy. So again, that comes under kinetic energy. Heat energy. So vibration of atoms and molecules. So that will come under heat energy, and that is again the energy that moves. So that is kinetic energy. Okay, so we have studied about the law of conservation of energy, right? Energy cannot be created nor be destroyed. So we have so much of energy, but no, it is not created, neither it is destroyed. So it's just transferred from one form to the other, and that is your first law of thermodynamics. And energy will always transfer from high to low. So a simple example is your coffee cup. Now you have a very hot coffee. So what happens is your heat is transferred from your hot coffee to your container, okay, the coffee cup. So that is the idea. Any energy transfer happens from high to low. And but do you expect that all your temperature, all your heat will be transferred to your coffee cup? No, it's not possible. So energy transfer is not 100%, or it's not 100% efficient. Okay, and we spoke about potential energy and we spoke about kinetic energy. Mostly this potential energy is converted to kinetic energy. So we stand in a position and then we start moving. Now, for example, people who run, the athletes, when they run, they stand for some time. They just take a deep breath, they stand, and then they start moving. So when they stand, that is their stored energy, and when they start moving, that is their kinetic energy. So potential energy is stored, and kinetic energy is when we start moving, and the energy needed for that is your kinetic energy. Yeah, so these are the categories that we saw. So under potential we have chemical energy. We spoke about the molecules and the atoms, how they are held together. Nuclear energy, the nuclear weapons, we spoke about that too. The stored mechanical energy is that rubber band example I told you. Gravitational is the ball. If I'm going to throw a ball from a height, so that needs gravitational energy. If we see the kinetic, again we saw a lot of examples. The light energy, the heat energy, and anything that moves. The sound energy, even what we speak, okay, that is kinetic energy. Electrical energy. Now here are some examples for how energy is transformed from one to the other. Now for example, so when we strike a match, chemical energy is converted to heat. A photovoltaic cell. light energy is converted to electricity. Photosynthesis, light energy is converted into chemical energy, okay, and it is stored in the form of glucose. So these are some very common examples that is happening in and around us in our day-to-day life. Okay, so energy is transferred from one form to the other. But this energy, for all this energy, we need a source. No, we need some resources. We get it from some place. So based on that availability, we classify this energy sources as non-renewable and renewable. Here I have given a list of some sources, and I've classified that. So we will see what form of energy it comes under. Petroleum, chemical energy, uranium, nuclear energy, wind is moving energy, geothermal is heat energy. Okay, so every resources comes under the energies that we saw just now. Okay, now what is this non-renewable resources? How do we classify that? So it's mainly that if the sources can't be replenished in a short period of time. So you have some material, you have some source, and it is there for a long duration. But at the same time, when you take it, it cannot be renewed or replenished in a short duration. Hope you get it. Or there is a large amount of that material, but as we start taking it, we are trying to consume it, you cannot get it in a you cannot get it back. So in other words, they are known as exhaustible resources. So some examples, your coal, your natural gas, petroleum. Okay, so you can categorize everything under fossil fuels. So fossil fuels like oil, natural gas, coal, and what are they? They are formed from buried remains of plants and animals that lived millions of years ago. So here again there is a list of some resources: sun, coal, and why are we using that? For electricity. For oil, why are we using that? For transportation. Gas, why do we need that? For cooking. Again, here also I have given a list of different forms of energy. Okay, so basically, why do we need energy? A broad classification: for residential uses, for commercial uses, and most of the energy is in the world is used for transportation. So if I say residential uses, we cook, we just light up, we heat, we watch TV, for everything again, and especially during this lockdown period, we definitely need energy. Okay, and commercial uses, if you just imagine big industries, if you just visualize the industries, there will be big boilers. So for heating those boilers, and there are some industries which needs cooling. So mainly in industries, it will be either heating or cooling. If you visualize an office, a big IT company, so there will be a lot of computers. So what do you need there? You need to power up the computers. You need to power up the rooms. You need electricity for that. So that is the purpose or that is the need that is for commercial purposes. Next is for transportation. As we all know, we take our scooter, we take our car, any vehicle that has to run in the roads. You need petrol, you need some fuel. Okay, it also includes aircrafts, trains, ships, and pipelines. Okay, with this we stop here. Okay, we are done with the topic energy. So it was so interesting to discuss. So here I've given some pictures. So you can see a dog that is barking. So what energy is that? It's sound energy. And here you see the windmills and some solar panels. So it is wind energy, right? Here again it's light energy converted or stored in the form of electricity. Here it's lightning, again it is electrical energy. And here this is thermal energy, the example that we discussed about a hot coffee in a cup. And this vehicle needs it is in moving, and that comes under kinetic energy. So class, hope you found this interesting. So meet you in the next class. So don't forget, cherish chemistry. Thank you all.